In this video, we're going to work on examples 12.7 to 12.12 from your book. If you'd like to follow along, open the Chapter 12 classwork.xlsx workbook from my courses and click the EX 12.7 to 12.12 worksheet tab. If you get a warning that says this workbook contains links, just click Don't Update and then you're ready to go. In example 12.7, we're going to run a Monte Carlo simulation, and then in 12.8 to 12.12, we're going to analyze the results. So the first thing that we need to do is to set up our distributions. So first we're going to set up distributions in cells B11 and B12. So if we just click the distributions, or we add the distributions, we get a base case which we don't want. So I'm going to select the range B11 to B12, which is where we're going to put our first two distributions, and I'm just going to hit the delete key. Now I'm going to click cell B11. I'm going to click the Analytic Solver tab. Now remember, if you don't have the Analytic Solver tab, you will only have that tab if you purchase the Analytic Solver add-in for $25 following the instructions that I had on my courses. If you did not buy the Analytic Solver add-in, you're going to have to complete this in the computer lab. So now that I've deleted what's in cell B11, I'm going to click that Analytic Solver tab. In the simulation model, I'm going to click Distributions. In this one, they told us to use a uniform distribution. So I'm going to click Uniform, and 600 million is going to be the lower, and 800 million is the upper. In fact, I even wrote the commas in my book so I could see the number more clearly. So lower, 600, 000, 000. Then I'm going to click in upper. I'm going to backspace 800, 000, 000. Now what I need to do is click away. If I click save, it'll just draw the distribution. Then I need to click save again. So if I click away, it draws the distribution, and then I only have to click save once. Now I'm going to do the same thing for cell B12. This one is going to be a log normal. So I could just type the formula that they have in the book, equals PSI log normal. And there it is, so I can double click that, but I'm going to use the distribution button. So I'm going to hit escape and click distributions and choose log normal. And for this log normal, the mean is going to be 150 million, 150, 000, 000, and my standard deviation is 30 million. So click after the 5, backspace, 30, 000, 000. So as I said before, if you click save, it just draws the distribution. Then you have to click save a second time to save the distribution. Now we want to enter the triangular distribution in cell C18 to F18. Unfortunately, we can't do that all at once, but we can copy the cells. So I'm going to delete the range C18 to F18. Again, if you don't delete the numbers that are there, you get this base case, which is going to mess up the distribution. So I'm going to click in cell C18, and this time I'll actually type it. So I'll type equals PSI triangular. It's my second one, so I'll double click it. And it had 2%, 3%, and 6%. So 0.02, comma, 0.03, comma, 0.06, and close up the parentheses. Now I hit enter, and I want the same formula in cells D18 to F18. So I just click that cell, grab the fill handle, and drag it out, and notice that I have different cells because each one of them is now randomized. And in each cell I have my psi triangular formula with the same parameters, 2%, 3%, and 6%. Now I'm going to select the range C20 to F20. That's the last distribution that we need to put in. I'm going to hit my delete key, and that one is going to be triangular for 15%, 20%, and 25%. So I'm going to click cell C20, distributions, and triangular. Minimum 0.15, likely, backspace 0.2, max on the right hand side, backspace 0.25, click away to draw the distribution, click save to save the distribution, and now making sure that you're on cell C20, grab that fill handle and copy it out to cell F20 and make sure that each one has the correct triangular distribution. If you want to get rid of the green triangles, select the range C20 to F20, click the yellow diamond, and click Ignore Error. Now that we've entered all of our distributions, the second step is to set the output cells. So scrolling down, they said that they want all of the green cells, the cumulative net profit for each year and the net present value, to all be result cells. So I'm going to click on cell B28 and select the range B28 out to F28. Hold down my control key, click cell B30. That holding down the control key allows you to select a non-continuous range. And then I'm going to click the results button, so making sure that I'm on that analytic solver tab. In the simulation model group, I'm going to click results. Then I'm going to click in cell. And notice now each one of those cells now has a plus psi output, open parentheses, close parentheses. So it has the original formula plus a psi output. We could have typed just the psi output at the end of each formula, but it was easy just to do it in one fell swoop and set all of the result cells using the results button. Now, the third step in a Monte Carlo simulation is to click the options button. So making sure that you're still on the analytic solver tab. In the options group, you're going to click the options button. Now in the book, they want you to run 10,000 trials, but unfortunately our software is limited to 2,500 trials. So I'm going to click where it says trials per simulation. I'm going to select it and just type 2500. Now we are only going to run one simulation. We could run more than one simulation and then get an average of all of our simulations, but we're just going to run one simulation with 2,500 trials. Now we want our sampling method to be Monte Carlo, and that's all we need to set for this, so we click OK. Once we've done the 3 steps, set the distribution, set the output, and set the options, all we need to do is run the simulation. So making sure that you're still on that analytic solver tab. In the solve action group, we're going to click the down arrow under simulate and then click run once. And we get a chart for all of our variables, every cell that we put a distribution in. This is now the end of exercise example, 12.7. Now we're going to move on to example 12.8, where we're going to answer some questions about the output. So I'm just going to close this, and I will call this plot of variables, and click save. It takes a moment to save it. Now we're going to move on. In example 12.8, what is the probability that the net present value over the 5 years will not be positive? So I'm going to scroll down. our net present value over the 5 years is contained in cell B30. So I'm going to single click cell B30, and then I'm going to double click to display the results, and we can see over here. So what I'm going to do is I'm going to drag that red dotted line where it says lower. I'm going to hover over it until I see the two-headed arrow. Then I'm going to drag it to where it shows 0. Now what I can do is I can click the 6 and just type the number 0 and hit enter, and I get a 0, and we can see over here that there's just a 0.8% chance that our net present value is going to be less than 0. So we can see 94.92 and 5% means that we have a 94 plus 5 is 99.92% chance that our net present value is going to be above 0. That actually makes me feel pretty good about this simulation. The second question: what are the chances that the product will show a cumulative net profit in the 3rd year? So I'm going to close this chart. Just click the arrow in the upper right hand, the X, in the upper right hand corner. Now for our second question, the cumulative net profit in the 3rd year is contained in cell D28. So I'm going to click cell D28. I'm going to double click, and I show the results for this particular cell. Now it asks what is the probability that it will show a cumulative profit. So what I'm going to do is where it says the upper and it says -89, I'm going to click there and I'm going to type the number 0 and hit enter. And we can see here that the probability is actually 0 because that disappears. So we have 95 and 5% means that there is a 100% probability that we will not have a positive net present value. Close that chart. Third question: what cumulative profit in the 5th year are we likely to realize with a probability of at least 90%? So that our cumulative net profit in year 5 is contained in cell F28. So I'm going to double click cell F28, and now it asks for the 90% probability. So to have a 90% probability, we want 90% to the right and 10% to the left. So where it says 5% below the lower, I'm going to single click there and just type the number 10 and hit enter. So we can see here that there's a 10% probability that our profit is going to be below 458 million, which means that there's a 90% probability that it will be above $458 million. Now in the next example, example 12.9, they want us to do a confidence interval for the net present value. So our net present value is contained in cell B30. I'm going to single click cell B30, and then I'm going to double click to display the results. And we can see in the box over here that we have a mean of $202 million and a standard deviation of about 70 million. Now you ran a different simulation. You should get similar results but not the same results. In fact, if you got the same results as me, I'm going to take you down to the lottery office sometime next week, and we're going to buy a lottery ticket together because that's how unusual that would be. So anyway, what we're going to do is we're going to create the confidence interval using the formulas that we see at the bottom of page 391. Unfortunately, in this box, they give us a 90% confidence interval, not a 95% confidence interval, because 5% of the numbers are lower than 88 million, 5% of the numbers are higher than 314 million, so it means that 90% of the numbers are in between. We want a 95% confidence interval. So to make it easier, I'm just going to copy down my mean and standard deviation. So my mean, I'm going to type that in cell A32, the word mean, And then in cell B32, I'll just type the number 202,303,061. Now in cell A33, I will type standard deviation. I'm going to abbreviate that. And then in cell B33, I'll type the standard deviation from our box, 69,968,467, and hit enter. So now we're going to calculate the upper and the lower range of our 95% confidence interval. So for our upper, what we're going to do is we're going to take our mean. So I've typed the word upper in cell A35. So equals, I'm going to click on the mean. Now I am going to copy this formula for the lower because the only difference between the upper and lower formula is we're going to change one plus into a minus. So there's no reason to type the formula twice. I'm going to type it in once using the absolute cell references, and then I can just edit the formula. So I take the mean, and I'm going to use an absolute reference for the mean, so when I copy it for the lower, it's still going to start with the mean. And then I'm going to add 1.96 multiplied by the standard deviation. So I'm going to click on cell B33, and I'm going to use my F4 key or type those dollar signs to change that into an absolute cell reference. And then I have to divide by the number of observations. We had 2,500, so I'm going to /SQRT. We divide by the square root of the number of observations. So the square root, open parentheses, 2500, no commas, otherwise you're going to take the square root of 25. Close up the parentheses, and then hit enter. So for our upper range, we get about 205 million, 205,045. I'll put in the commas in a moment so we can read it a little bit more easily. So in cell A36, I will type lower. I'm going to copy the formula from B35 to B36 using the fill handle. Then I'm going to double click the formula in cell B36, although I could also edit it in the formula bar. And again, the only difference is instead of adding 1.96 multiplied by the standard deviation divided by the square root of the number of observations, for the lower, we subtract the second term. So I'm going to double click in cell B36. It shows me the formula. I'm just going to click after the plus, backspace, change that to a minus, then we hit enter. So with 95% confidence, my net present value is going to be somewhere between 199,560,000 and 205 million. To see those numbers a little bit better, I'm going to select both of them, drag this out of the way, click my Home tab, and then in the number group, click the comma icon, and we can see that it's between 199 and 205 million. So our observations were very close together. They were not very widely scattered. In example 12.10, we're going to take a look at the sensitivity chart. So to see the sensitivity chart for our net present value, cell B30, that's already up. If it wasn't, you would just double click cell B30 to bring up this chart, and we can click the tab that says sensitivity, and on page 392 they explain basically what all of this means, but it basically shows the distribution and the correlation between the different variables. Now we're going to close up this. We don't have to save the changes, but if you'd like to save the changes, you can click yes. I'm going to click no, because we can always rerun the simulation. In example 12.11, we're going to create an overlay chart. So making sure that you're on the Analytic Solver tab, we're going to, in the analysis group, we're going to click Charts. On the left-hand side, click the bottom one, Multiple Simulation Results. The book says with an exclamation point, do not click multiple simulations, multiple simulation results. Now we're going to click overlay, and we have to choose our variables. I've already set up several simulations. We're on example 12.7 to 12.12. So under the outputs, I'm going to click the plus next to example 12.7 to 12.12. In the range B28 to F28, I'm also going to click the little plus sign. And the book tells us to just choose B28 and F28. So I'm going to single click B28, and I'm going to click the single arrow, not the double arrow. I've done that twice already. That sends all of the variables. You just want to click the single arrow for B28. And now I'm going to single click F28 and make sure once again to click that single arrow. And I click OK. And it produces my overlay chart, which visualizes the mean and the standard deviation and how scattered those observations are. In example 12.12, we're going to create a trend chart. So making sure you're still on the Analytic Solver, I'm going to click the Charts button. Again, multiple simulation results, not multiple simulations. This time we're going to choose a trend chart. So I'm going to click the plus next to example 12.7 to 12.12, and they told us to do a trend chart for all of the cells B28 through F28. So I'm going to single click B28 through F28 and click the single arrow. Again, clicking that double arrow sends all of the variables from all of the worksheets. So click the single arrow, and I've got B, C, D, E, and F28, and I single click OK, and there is my trend chart.